Hi guys, Mr. Teen Tutor here, and today we're going to be talking about polar coordinates and how to go from polar coordinates to rectangular coordinates and vice versa. So there are going to be two problems that we'll be working in this video. We begin with the first problem. We need to find the rectangular coordinates of 5, negative 4 pi over 3. So as you know, hopefully, hope you guys learned it. If not, that's alright. The general form for a polar coordinate is r, theta, where r in this polar plane is the distance from the origin. And of course, theta, you go a certain angle and then you draw r. And essentially, what we're going to be using to solve this problem is the unit circle. It's not a perfect one, but you understand what I mean. So what we need to do is we need to go negative 4 pi over 3 from the positive side of the x-axis, and we'll end up somewhere. So if you remember from a little earlier from simple trig, when you have a negative angle, you must go clockwise, and when you have a positive angle, you go counterclockwise. So because this is negative 4 pi over 3, we're going to start here and go we're going to go clockwise until we finish the angle. So we start here, and if we go here, this is negative pi, or in other words, negative 3 pi over 3. I'm going to write it like that because since our angle's in thirds, we'll know how much farther to go until the end of the angle. So it turns out we need to go negative pi over 3. In other words, pi over 3 clockwise, and that will be the end. So it'll be about right here, and then we'll just draw this distance of 5. And then this angle right here is negative 4 pi over 3. I'm going to draw it out here in blue. I'll do the best I can. Well, that turned out well. So this is negative 4 pi over 3. What's in blue? Now, there's another way you could write negative 4 pi over 3. If you notice for a second, if you go clockwise and you were to finish this off, I would go 2 pi over 3 more. So in this case, this right here, this point that we're at, this also represents 2 pi over 3. Now we need to find the coordinates of 2 pi over 3. So in order to do that, let's start with pi over 3 in the first quadrant. Half, root 3 over 2. Those are the coordinates. Now 2 pi over 3. We're in the second quadrant. The the y coordinate is obviously positive, so that stays the same. This is now negative because we're in the second quadrant. So this is negative half, root 3 over 2. And these coordinates right here also correspond to the coordinates of negative 4 pi over 3. Now in order to find the rectangular coordinates, we're going to do this. X in the rectangular coordinate plane is equal to r cosine theta, and y is equal to r sine theta. So let's come over here so we can show our work. Make sure you do that, guys. It's important when it comes to mathematics that you show your teacher and yourself actually the work you do so that you understand how to attack the problem on an assessment. So let's do x right here. So x is equal to r is 5 cosine, and even though we've identified the fact that 2 pi over 3 is the same, rather the coordinates of 2 pi over 3 are the same as the coordinates of negative 4 pi over 3, because theta is originally negative 4 pi over 3, put negative 4 pi over 3 here. And then y equals 5 sine negative 4 pi over 3. Same thing. So if we look here, we have 5 times negative half, and we have 5 times root 3 over 2. So this equals negative 2.5, and this equals 5 root 3 over 2. That's tough to see right there, that 2. I ran out of room, but our rectangular coordinates are negative 2.5, 5 root 3 over 2. There you go. That's a clear 2. There you go. Those are rectangular coordinates that correspond with this polar coordinate right here. So now we're going to go the other way. With this second problem right here, we're going to find the polar coordinates of this rectangular coordinates. So now we're going the other way, but this time we're going to be using different equations to get there. So in order to get r, it's like the Pythagorean theorem. X squared plus y squared is equal to r squared. So square root both sides. So now let's just enter this in. So I have -1 squared plus 2.6 squared equaling r. So r equals, plug this in my calculator and see what we get. So when I perform this operation, I get 2.79. I'm going to round to the nearest hundred. Now, to find the angle, there's some rules that we must follow here in order to get this problem right. So here's a rectangular coordinate plane, alright? Not polar, we're sticking with rectangular for now. -1 comma 2.6. In order to find the angle now of the polar coordinate, you first need to determine where this coordinate is. Which quadrant is what we're looking for. Which one? This one, right? Because -1 here, 2.6, so this is the second. And just to refresh your memory, this is one that's 2, this is 3, and this is 4. Now when you find the angle, you are going to take the tan inverse of y over x. However, understand this, you're not going to just only take tan inverse of y over x in some of these quadrants. In some of these quadrants, we're actually going to have to do something extra. So, in the first quadrant, to find your angle, you just take tan inverse of y over x. Okay, not bad. Now, in the second quadrant, though, this is where we have to do something extra. We actually have to take the tan inverse of y over x plus pi. That's not a clear one. Let me write that again. So tan inverse plus pi is how you find theta in this quadrant. Remember, pi, of course, is a radian measure. So in terms of degrees, whatever degree you get here, you add 180 to that. In the third quadrant, it is the same thing as the second quadrant. Tan inverse of y over x plus pi. And then in the fourth quadrant, it's the same as the first. So one way you can remember this is that when x is negative, like if x is negative, then you will, actually let me not phrase it that way, that may confuse you a bit. One way you can remember this is the fact that if you're in 2 and 3, in other words, x is negative in both cases, then it's going to be tan inverse of y over x plus pi. But if you're on the positive side of the x-axis, then it's just tan inverse of y over x. So let me go over that one more time. If you're on the negative side of the x-axis, it's tan inverse of y over x plus pi. If you're on the positive side of the y-axis, it's only tan inverse of y over x. Alright? Make sure you nail that, because if you don't do this correctly, you could get it wrong on a test or quiz. So Mr. Teen Tutors wants to make sure that that doesn't happen to you. Alright? So make sure you come up with a way to remember this. You could use my way or you could use your way. Doesn't matter, as long as it works for you. Continuing on now, because we're in the second quadrant, we need to use this. So if we come over, let's go up here actually. So theta in this problem is equal to the tan inverse of 2.6 over -1 plus, and if you want to put it as 180 degrees, that's fine, but I'm just write this as pi. Because when it comes to trig, we're really going to stick with radian measures. So I'm going to enter this into my calculator, and you know what, I'm going to get this in degrees because in terms of radians, it may not necessarily be, you know, a nice fraction, maybe some crazy one. So let's just put it in degrees, because I think we can all relate to that more than radians. But understand that in the future, you'll make good use of radians more than degrees for later trig chapters. Alright, so when I perform this, I get the following degree measure. 111.04 degrees. Now, of course, if you want to find what this is in radians, then you would take this times 180 over pi. I'm not going to do that because if you think about 111 times 180, really, that's going to take forever. But yes, to find radian, the radian measure, multiply this by 180 over pi. But I'm just going to keep this in degrees because this seems a bit simpler. So if we come down here, our polar coordinates are 2.79, 111.04. And make sure you include the degrees. Because if you don't include the degrees on your test or quiz, your teacher may think that this is a rectangular coordinate. So it's important that you include the degree measure if you're writing this in degrees. If you're writing this in radians, then your teacher will recognize it. But don't make that careless mistake. I don't like careless mistakes, and I don't want you guys to make them. I want to make sure that you guys perform everything correctly and get it right. So these are the polar coordinates for negative 1, 2.6. And then if we go back to the first problem, these are the rectangular coordinates. Yeah, it's tough to read, but anyway, that's the case. So I hope this video has helped you in understanding how to go from polar to rectangular coordinates and understanding basic concepts about polar coordinates. If you have any questions, just write on my channel and I'll be glad to help you out.